All right, ladies and gentlemen, we are doing 5B part 2. In terms of this particular topic, this is extremely long. That's why you have to 5B. I have a feeling at this moment in time seems to be one of those critical early parts where if you don't master this area, the rest of the area is you can just forget about it. And so we're doing example. We're up to 5D. Now, as you have noticed, I'm individually tackling each of these questions because they each represent a specific form of factorization. And that is not the easiest to actually tackle individually. Now, I mean, if you get stuff like this becomes a really big issue. Because first of all, knowing something is half of the battle, as Sun Tzu Art of War says. Knowing is half way towards victory. You must realize that in this particular case, your A is not a single letter or number or a phrase. This is the entire expression. So in this particular token, this thing still is A squared minus B. It's just that your A value is the entirety of x plus 3. So remember, we still need to adhere to this particular form. You just substitute, remember substitution, there we go, substitution from the previous topic. Substitute A with x plus 3 minus, now minus B, now 4, well, first of all, 4, if you square root of 4, it becomes 2, doesn't it? So minus B. X, so this is A plus B. Okay? And if you factorize, you need to simplify this again. You make, x, 3 minus 2 is 1, positive 1. 3 plus 2 is 5. And so you'll get this. Now, once you get into year, if you're doing methods and stuff, you get to year 11 and stuff, you'll have to deal with questions like this in that sometimes the factorized form of these looks completely nothing like the ones that you come from. This is an example. This is your first introduction to these, how should I say, improvised type question that you have to do some tricks to it. Like you have to add and subtract something from it to basically make them sensible, essentially making them a lot harder than they essentially making them a lot harder. Okay, so that was example 5. Let's look at example 6. Okay, factorize difference of perfect square. Using surds. Okay. Now we've got some really bad news. That wasn't even the bad news. Now we're getting to some real problem here. Okay, so x squared minus 10. Immediately, most of you probably will be like, hang on, 10 is not a square number. You can't do 10. 10 is not a square number. Well, yes, you can. Square root 10. How do we know this? If you square root of 10, you get 10. So any number essentially can be a square number. It's just that once you apply the square roots, you will not get any decent result. You just simply get a square root sign. So if I want to split this down, you still need the a squared, a minus b, a plus b. A, we know it's x. X squared, square root of that. But if you square root a 10, you get a square root of 10. That essentially deals with all of this, okay? Something else. Part B. Okay, so looks like I need to do every single example because they each represent something weird. Okay, now square root of 24. This becomes a bit more problematic. As you know, square root of 24, you can simplify to a certain degree. 24 is 6 times 4, okay, or 2 times 12, which is 3 times 4. So we can say it's 4 times 6 because 4, we want the 4 because 4 is a square number. I'll be back in a sec.